Good afternoon, everyone. Welcome to the virtual 2020 DFW Solar Tour. My name is Eric Pratt. I'm a member of the North Texas Renewable Energy Group. I'll be the moderator for this question and answer session. I want to give a few thank yous to those who made this event possible. Thank you to our Terawatt sponsor, Dallas College, whose financial, technical, and volunteer support were crucial to the success of this virtual event. Thank you to this session's homeowner, Mike Renner, for welcoming us to visit his residence virtually. Thank you to everyone in the NTREG Solar Tour Committee for putting this event together for the 11th year. And thank you to all of the attendees of this Zoom meeting for your interest in clean energy and sustainability. Just a little bit of Zoom etiquette that we've been going over for each session. This question and answer session is actually scheduled for 60 minutes since we have two 30-minute sessions back to back. And depending on how active the question and answer session gets, we can go a few minutes over that. Your mics were muted when you first entered the meeting, just automatically as a courtesy to the other participants. To ask a question, please either unmute your mic or type your question into the chat, and I'll be watching those and can ask the question from Mike, for Mike when he has an opportunity. And the meeting is being recorded for those who were unable to attend at this point. So with that, I'll turn it over to Mike.
Good afternoon. It's a wonderful day here in North Texas. The sun is shining and the wind is blowing. We're really off grid. We do have grid power here. For the last 6 years, even though I've had grid power, we have not used it. The only time that I use grid power now is to maintain a high level of charge of batteries in case there's no sun shining or very little wind blowing, and to keep the battery topped off at a high level. This installation has lead acid batteries, which are the older technology. And in order to create a real long life on the batteries, it's to keep them at a high level of charge for as long as possible. So therefore, I used to use a generator in the past to charge them up when they started getting low, but they're noisy and require putting fuel in them. So this last year, I've decided I've put one item on the grid, which is a battery charger. In case we need to charge batteries, I'll use it, just flip on a switch and we can charge batteries with that. So I'm open for any questions. Feel free to ask.
I was going to say, has everybody seen Mike's video?
Might be a good idea to run it.
Okay. Let's see if I can get to that to share it.
The video is a short video, and it's basically covering the system in the garage. For some reason during editing, the system on the house got lost. I don't know what happened, but have any questions about the house, we can go through all the house explanations.
Mike, this is Rosa while we're waiting for that. Oh, there's the video. I can ask later.
Oh, go ahead, Rosa.
Okay.
I'll hit start when you're done.
Where do you source your materials?
What do you mean? Where do I source my materials?
Yes.
Basically on the internet. I do a lot of shopping at different solar suppliers, Outback. I research through them. They have a lot of, I download manuals on different components to do research on what I want or what the specifications are to find out what they'll do. And then I'll actively look at different vendors that sells the units and try to find the best price. But I've also discovered that the best price may not be the best option depending on where they're at because there's shipping cost involved. So if I can find somebody closer or local, even though the unit might be a little bit more expensive, the shipping costs may offset that. So I do a lot of shopping around to find my materials.
I just didn't know if you had some old favorite standbys that you knew you could always go to and be able to find what you needed.
Well, one of the major suppliers I go to is called Alt-E Solar. There's also another place out in California, which is quite a ways away, which is called Wholesale Solar. And they're real friendly when you do DIY projects, as to help you how to set up the system and give good information and technical support. One of the big sources when I first started this, there was a magazine, which unfortunately no longer is production, was called Home Power.
Yeah.
And through Home Power magazine, that was at the beginning my favorite source to go to for information on how systems work and on vendors that make the different components of the systems. They had a long list of people who sell information, and that was one of the best magazines that I've found. And I'm just sad that they no longer produce that.
Thank you.
Okay, I'll run the video.
Energy Group and the American Solar Energy
Let me
Society. I am
restart
Mike
it.
Renner. Hi, welcome to the DFW Solar Tour, sponsored by North Texas Renewable Energy Group and the American Solar Energy Society. I am Mike Renner.
Is the audio
and
coming through on your
This
side?
is the Renner residence. We've been off-grid for over 6 years. We do have grid here at this location, and we use it for backup. For the longest time, I just used a generator when the batteries got low, and decided that it is much cheaper and more economical to use the grid on rare occasions to keep the battery at a high level of charge in order to maintain long life out of the batteries. Behind me is one of the solar systems that I've put together that actually provides air conditioning for the garage, and it also seconds as a swing set. There are 12 panels and have a total combined output of 2,800 watts. This supplies the power for the air conditioning in the garage. This is the garage that the solar swing provides power to run the air conditioning in it. I've installed a solar shade screen made for greenhouses on top of the metal with the airspace, and this reduces the metal temperature from about 135 degrees down to about 101 degrees, which is the outside temperature for today. So it mainly helps to keep the garage a lot cooler, so I don't have to run near as much air conditioning. So looking inside, the two air conditioners that we use for this thing, there's two units, and they're just window air conditioner. One's a 12,000 BTU and the other one is an 8,000 BTU. Everything that you see here is a DIY project. Nothing has been done professionally installed. I've done it all myself with some help with my wife and some friends.
Mike, how much?
Several.
I'm
Go
sorry.
ahead.
How much how much electricity do you produce on an annual basis? Do you know?
On an annual basis, ooh.
How about monthly?
I haven't. Monthly, during the summertime, an average of around 2,000, anywhere from 19,000 to 2,000. No, I'm sorry. Yeah, 2,000 to 1,900 kilowatt hours during the summer months. In the wintertime, it drops off a little bit. There it's around maybe, 1,500, 1,200 kilowatt hours per month during the wintertime. I'm looking at my electric bill here that I just received for last month. which is $34. Now, out of that $34, $15 is my monthly just to have the service. So we use $19 worth of electricity for the month of September, which is really not bad. Consider that for that month, we used, let's see, around 1,500 kilowatt hours. So having an electric bill for $19 or paying for $19 with electricity bill is really a big benefit that I see, especially after I retire, not having such a large electricity bill. Now, one thing that's unique about this property is since our system is not grid tied, it is actually a standalone system. Your lifestyle changes a little bit. You learn to live with the weather. You learn to watch the weather to find out what's going to happen tomorrow and the next day, because that depends on your electricity usage. Most of the electricity that we use is during the daytime when the sun is shining. So therefore, we're actually not using any power out of the batteries. It's all being produced by the sun and by the wind. At night, all our major loads are turned off. We just have a few things on at night, maybe TV and lights and so forth. And we will run off the batteries at night. But the batteries are normally at 100% by the time sundown goes down. So the house is very energy efficient. We have virtually no air conditioning on at night because we have a lot of thermal mass in the house. So that gets us through the night. By the time morning comes around, our batteries are normally still at about 90% state of charge. And that is without any wind. If the wind is blowing at night, there's been several mornings where the batteries are still full early in the morning. So it's a little bit different living off grid as compared to being on the grid, doing whatever you want, whenever you want. Being off the grid, you learn to live with Mother Nature and have respect for it.
Mike, when did you first start your journey on finally getting to being off grid?
Well, the journey started when we first built this house. We built this house in 1998 during that summer and moved in December of 1998. I've always been interested in renewable energy, and we bought this property mainly because I wanted a wind turbine, which you can't do a wind turbine in the city because of code restrictions and height problems. So we bought 5 acres out in the country because I wanted a wind turbine. That was the basis of us moving here. Over a period of time, as we got the house finished, the house was not finished when we first moved in because our house sold a lot quicker than we had expected and had to move out in a hurry. So the very first year, we were still working on the inside of the house. And after we started installing a little bit of solar. I started out with small solar PV system. Actually, I bought those cheap panels. Well, I thought they were cheap at Harbor Freight. They're little 5-watt panels that you use to run a deer feeder. And I bought 3 or 4 of those and just hooked them up to a battery with a cheap charger controller just to run a few lights. Well, over a period of time, I expanded those and bought a few more panels and ran a few more lights, up to the point where I discovered these little 5-watt panels are really expensive when you divide it by the amount of power they put out. So at that time, we were going to a meeting in Fredericksburg at the Renewable Energy Roundup, where there were many, many vendors out there. And I discovered the much larger panels, which cost more, is actually cheaper than $1 per watt. Well, this was back in probably 2002 or 2003. And there was a vendor that was selling panels there. They were 120-watt panels. And back then, those panels were running around $400 a piece, which by today's standard is very, very expensive, but that was still a lot cheaper than the little 5-watt panels that I was buying to get the same amount of power out of it. So that was the beginnings of my really first solar system. I bought 2 panels in Fredericksburg, brought them up here, put them up on the roof, ran a small inverter with them, and slowly started expanding the system year after year to where I could actually run a small window unit, and it just kept growing and growing. So it's been a long journey. We didn't do all this overnight. And I guess you might say I'm addicted to solar. I love to watch the power that it produces, knowing that it's free, knowing that I'm not polluting. And I'm just addicted to it. So I keep expanding the system year by year, and also finding ways to make the house more energy efficient little by little. And it really pays off.
Mike, there are 2 questions in the chat box. Let me read them off one at a time. The first question pertains to how many KWs are installed on the house? What direction does the roof point? What is the vertical inclination? And then I'll come back to the second question after you finished answering.
Okay. The size of the system, we have about 12 kilowatt system. Now, all of that is not on the roof of the house. There's about 3.5 kilowatts that's on the house. There's another 2.8 kilowatts that's on a solar swing that actually powers the garage. There's another 2.2 kilowatt on a solar trailer, and there's a 1 kilowatt solar tracker, and a couple other smaller units that's portable I can move around that produce probably another 2 or 3 kilowatts. So all in all, it's about 12 kilowatts of solar. We also have a wind turbine, and it is rated at, I think it's 7,500 or 8,500 watts at a 28-mile-an-hour wind. The house, I designed and built the house ourselves. The roof faces south, and it is at about a 30-degree angle, which is optimal for the climate that we were in, or for the sun angle that we were at year-round. What was the last part of the question? I forgot.
Last one is what is the vertical inclination? I guess.
Yeah, it's 30. The roof pitch is at 30 degrees. So they sit there permanently like that. The swing set, that is adjustable. We adjust it seasonably for wintertime, spring, fall, and so forth. Also, the solar trailer and the panels that you see down at the bottom, they're also adjustable. And we move them manually during the day, 2 or 3 times during the day, which they move very easily because they're center balance, and they're very light. You can move them with one finger. And then we have poles on both sides of them to stabilize them. And it's a pole it's actually electrical conduit. There's one pole inside the other pole, and we have pins to where you can expand and contract the poles. The solar tracker moves by itself all day long, and it operates off a deer feeder. So it pretty much tracks the sun all day, once an hour. It runs for about 15 seconds every hour and pretty accurately follows the sun. Now, the days are shorter in the winter as they are in the summer. So to compensate for that, on the little, what's called the deer feeder timer, I can either add or subtract an hour or 2 as needed for the different seasons. At the end of the day, when the panels are all west, sun goes down, I have a manual switch that I can switch it back to east, pull the panels all the way to the east, and then flip the switch again, and it's ready to go the next morning.
Okay, another question has been added, but that's wind related. But before you leave the solar aspect, here's another question, which in your situation might be different from what this individual is facing. If your energy needs increased because of, say, room additions to your property, what is the course of actions on an existing system if your south-facing roof space is limited?
Well, if you're limited on a south-facing roof, another option is to put some panels in the yard. You can do a ground mount system. Some cities have ordinances about they don't want to see them, so you can put them below the fence line. Or if you don't have problems with city ordinances, you can put them up on a pole and also have a tracker put onto them, which increases the production rate by about 20 to 30% because they track the sun. So you do have some other options by putting panels out in the yard.
Mhm. Okay, here's a wind-related question. So let me read it in its entirety. First question is, how tall is the tower? The tower brand and model, is it self-supporting or guide? Did you perform a full engineering design on the tower to handle a high-speed winds? What max wind velocity is the tower turbine designed to handle? I can come back to each question as you go along. The first one is, how tall is the tower, and the tower brand and model?
Okay, as far as the tower brand goes, it really does not have a brand because I built the tower. I found a surplus place that was not too far from me that had all these metal sections that was part of a tower in a food processing plant. I had no idea what the tower looked like, but they just had these sections laying out there. There were 17-foot sections. And I bought each section for like $35 a section, which was dirt cheap. It was basically the cost of scrap metal. I bought all these sections, designed it into a triangle, and welded it all together when it was on the ground, and then bolted each section to the next section. I then had a crane come out, and we set it up using a crane. Now, the foundation has a 10, 15 yards of concrete in it. Where we live, there's a lot of rock. We had fun digging a hole to get the foundation in, and then there's rebar pounded in the rock and welded to the base of the tower. The first base of the tower is actually down in the hole, welded to the rebar that's pounded in the rock, and then filled with concrete. The tower itself is 100 foot long. The wind turbine is at 100 feet. The brand of the wind turbine is a Berge wind turbine. The tower does have guide wires on it. It's guided on 3 sides. As you can see, it's a 3-sided tower. This is the second wind turbine that I've had up there. The very first wind turbine that I had was a Chinese brand wind turbine. And I had it for about a year. And I've always had problem with it. It had vibration problems. And to find out, the blades were actually porous. So they absorbed moisture over a period of time and made them unbalanced. One day during a very, very heavy wind, they got so unbalanced that it caused a vibration in the blades. And one of the blades actually struck the pole that the blade is mounted on, and the wind turbine came apart. When that happened, as one of the blades fell, it actually broke one set of the guide wires, but the tower did not budge. The tower is actually overbuilt. I built it myself. I did not have any engineering background or anything like that, but it is very, very strong. We have over 100-mile-an-hour winds. And that day when the wind turbine came apart, we had 60, 70-mile-an-hour winds with one whole side of guy wires loose from the tower because it snapped off the anchor where one set of guy wires were at, and it did not budge. I built the tower originally for the bigger Berge wind turbine, which at the time I didn't buy it because the cost was so much more than this cheaper Chinese one. I now know why the Berge costs so much more, because the engineering behind it and the quality behind it way exceeds anything that you can get from these Chinese companies. And it is manufactured in Oklahoma, here in the United States. So I do get really good support from this company. They've been around for a long time and did a lot of research and decided that it was the best one that I could find at the time.
Okay, as an extension to this wind tower layout and design, did you run into any issues with the permitting agencies because of the closeness of that to your house? And
No,
any
I had no,
insurance issues?
had no problems with that. We are out in the country and we're not inside any type of city limits. So there was no permitting required. The wind turbine is far enough to where if it does fall for whatever reason, it will not fall on any structures. So there has been no issue as far as permitting goes out in the country.
Okay, I guess I have one more question now. Since you are off the grid, are there any restrictions in you, say if you generate excess electricity to say pump it to your next door neighbor? And if he's grid connected, are there issues?
Well, I quite don't, do I have grid connection issues? Is that
No.
what you're asking?
No, you said you're off grid.
Right.
So your next door neighbor is probably grid connected.
Yes.
Is there any restriction on you exporting your power to him?
Well, since I am disconnected from the grid, I do not export any power to the grid whatsoever. We store it in batteries, and we also have a tendency to store cooling in the summertime because of the thermal mass in the house. And we can also store heat in the wintertime, which makes sure that we use a constant load off the wind turbines and off of the solar.
Thank you. And there's another question relating to that. Many people die working around towers each year. And I guess this is more of a safety note, be safe.
Is that a question about people dying on towers?
Yeah, no, the question was many people die working around towers each year. Be safe. That's a cautionary note. And I guess there's a follow-up line which says, show us more about the thermal mass in your house.
Yes, well, the first part of that statement is yes, that is true. You do have to be safe on towers when climbing. You have to make sure you have the proper time or climbing gear and that you are strapped in at all times. Normally there's 2 lanyards that you hook up to your belt. So as you're climbing up, you always have one lanyard that is connected to the tower at all times. So if something does happen, you will not fall off of the tower. So there are a lot of safety things that go on with climbing towers. I've read a lot of safety procedures. I do climb up there from time to time to do inspections. So far I've had no problems and there's been no issues here with the safety on the tower. What was the second part?
The thermal mass in your house.
The thermal mass of the house. Yes. When we built this house, we built it out of lime block. It's very similar to cinder block, except that it's made out of lime, which is almost twice the weight of cinder blocks. The cinder block or the lime blocks are also filled with concrete, adding more strength and more thermal to them. The blocks are insulated on the outside of the house. So the blocks are only exposed to inside air conditioning or heating temperatures. So when the blocks get to a certain temperature, they have a tendency to stay there. Where most stick houses, you'll see a temperature swing go up and down on a 24-hour basis. In our house, the temperature is very stable. So if we keep the blocks cool or during the day when the sun's shining with the air conditioning running, at night, all that coolness is released into the house at night and we do not have to run air conditioning at night. Same thing in the wintertime. During the wintertime, we heat the house up during the day. At night, those blocks are warm and re-radiate the temperatures into the house at night. So that really makes a big difference on the efficiency of our house as a thermal mass.
Eric, we have 1 minute over the assigned first session, are we going to spill over and start the next session, which goes off at 1:30?
Oh, but I think we just continue on. It's the same login, so we can just continue on for the next 30 minutes.
Okay, Mike.
I think I lost your voice.
No, the second session, I'm not sure
Oh.
if you're going to start from
Okay.
scratch or you have a different set of presentations.
Well, would you like to have talk about the other systems that are on your property, Mike?
Yes, I'd be glad to. This is basically a hybrid system. So we have both wind and solar. And a lot of people, have asked me, how does that work? Well, since this is a battery operated system, all the solar panels and the wind turbine is designed to keep the batteries charged. So there are various chargers for the solar system, and the wind turbine also has its own charger to regulate the battery voltage. What we do is, since if there is wind, we always want the wind to have the priority to keep everything powered. The reason for that is we don't really want to run the wind turbine without a load on it. It can run without a load on it, but like anything, the blades will increase in speed, and anytime something moves faster, like your car or whatever, it'll have a tendency to wear things out quicker. So we have a tendency to want to keep a load on it. So the voltage generator or the voltage controller for the wind turbine is set just a little bit lower than the voltage controller for the solar turbines. So on any given scenario, say we're using a certain amount of energy and the sun is producing all that power because there's very little wind. The wind is also contributing. But if a gust of wind comes in and all of a sudden the wind turbine starts putting out more power than we're consuming, what happens is the regulators for the solar panels will actually cut back, and the wind turbine now will start putting in more power to the batteries rather than the solar panels. So that's how we regulate and monitor the voltages of the batteries to make sure that the wind turbine always has a load on it. Now, there is times where we've had the batteries are full, and it could even be at night, and a thunderstorm may come in where we have large wind gusts. There's a regulator on the controller that I can see, the little yellow light starts flashing, telling me that the wind turbine is being regulated, that the batteries cannot accept any more charge, and the blades start increasing in speed on the wind turbine, and I can hear that. Normally, if I'm home or even if I'm asleep, I could hear it, and I can wake up and I will go turn something on in the house. I can turn a water heater on. We have a hot tub. I can turn the hot tub on. And as soon as I do, that light stops to flash, and I can hear the wind blade slow down on the wind turbine to where it is putting out the maximum amount of power that it can put out. So there is a little bit of involvement when you're off grid. You are basically your own electric company. So there is some input that you have to do. It's not like being off grid where you have or being on grid where you have a whole crew at a power plant regulating everything. You are the master of the control of the systems that you're dealing with. We have, basically, you might say 3 separate systems here. There's the main system in the house. There's the solar trailers, which is also a standalone system. And there is a system in the garage. The solar trailer and the house, the battery buses are tied together. So any panels that are on the solar trailer or on the tracker or on the house can charge both the batteries in the house and the batteries on the solar trailer, along with the wind turbine. the wind turbine can also charge the batteries in the solar trailer and in the house. So each set of batteries has its own charge controller that regulates the voltage on the batteries. And since the batteries are tied together, they have a tendency to stay equal. And at night, when we draw power out, if there is no wind or sun, we actually draw power out of both sets of batteries, reducing the amount of any current that comes out of just one battery bank, which really makes it possible to where we only take about 10% out of the batteries at night. So it is a hybrid system. It is a unique system. It's a system that I designed and built to, for me and our system the way it works. I do want to be off grid. Having grid as a backup is nice because to me, even though it's $15 a month that I have to pay the utility company to have grid, I consider it as a cheap insurance policy. In the event something really catastrophic happens to my system and it goes down, I can still switch the grid back on. And that did happen at one time. Several years ago, we had a very severe thunderstorm and we actually had a lightning strike that I think it hit the wind turbine. It did not hurt the wind turbine. However, it took out all the inverters, all the charge controllers on the house and on the tracking system. It did not hurt anything in the solar trailers, even though they were connected to the system. And I believe the reason for that is because by law, the solar trailers do not have to be grounded. So lightning really didn't go through them looking for a ground. So for about a month or two while I was getting equipment replaced, we actually ran off of the two inverters that you're looking at on the picture there that's in the solar trailers. And it was in the month of August actually when this happened. And we kept two window air conditioners used at that time with these inverters to keep the house cool during that month until I got the rest of the system back up and running. So we really didn't need the grid then at that point because the inverters in the trailer were still good. But if they would have went to, then we could have just flipped the switch on. So for me, $15 a month for insurance for having energy when everything goes bad is really a cheap way of doing that and really increases our reliability. So we have multiple sources of power: the trailer, the garage system, the house system, the wind turbine. We also have a backup generator here, and then we also have the grid. So I don't think I've ever been without power here, even though some of my neighbors had from time to time. At one time, on a daily basis, I go out and look at the electric meter on the back of the house. And for a period of time, I went to look at it and it was dead. The meter wasn't, there's nothing on it. It's a digital meter and it was dead. So I couldn't figure out why is it dead. Well, I looked up on the pole where electric lines come from the grid and seen that a fuse was hanging down. Well, the first thing I thought was, well, the utility company cut me off because they were mad at me because I wasn't using power. So I called them up and told them that, hey, my power's out. And they said, okay, we'll send a crew out there. And within about 3 or 4 hours, they sent a crew out. They came out and they looked up at the pole and goes, yeah, your fuse is blown on the pole. And they asked me, goes, how long has that been blown? I go, I don't know. And they go, what do you mean you don't know? I go, well, I still have power on the house. What do you mean you still have power at the house? And he looked over and he see that my central air conditioner was running. I go, how is that possible? The fuse is blown. How were you getting power? And I showed him the system that we had. And he said, oh, okay. And I go, what caused that fuse to blow? He said, well, probably about a week ago, there was a real bad thunderstorm that lightning hit the power lines and it blew a lot of fuses out in different locations. And that's probably what happened to yours. But I never knew that the power was off on the grid for, the whole week. It's been interesting.
Okay, there's a question, Mike, relating to the batteries. The question really is, did you stick with one brand type or is it a potpourri of different brands and sizes?
We actually have like 3 different sets of batteries. The main set of batteries in the house, which I keep outside the house, these are flooded lead acid batteries, which is the old technology batteries. We've had these batteries since, oh gosh, I'm trying to remember, probably 5 or 6 years, maybe 7 years. And they're made by Trojan. These are industrial batteries. When they first came out, they used them for backup power for cell phone towers. So if the cell phone tower lost electricity, the cell operators would run off of these batteries bank until they can get the generators to come back online, so everybody wouldn't lose their cell phones. So we bought a set of these batteries, and they were industrial grade. They're heavy duty. They're about twice the size of normal batteries. They're rated at 460 amp hours at a 20-hour rate, or up to 610 amp hours if at a 100-hour rate. There's 8 of them. Each one of those batteries is 6 volts, so 8 of them connected in series gives us a 48-volt system. The batteries that I have in the garage they're a sealed lead acid batteries, and I imagine to buy them used. They also came from a cell phone operator. Actually, they were in a training center. They used to use these for training students that maintain cell towers, and every a year or two they trade out those batteries. Well, a friend of mine knew about these and they were going to get them out, so I got these batteries dirt cheap. There's 4 of them in series. These are 12-volt batteries, and there's 3 banks of them. Each bank has its own circuit breaker, and this is what maintains the inverter in the garage. The batteries in the trailer are also flooded lead acid batteries, and they are the golf cart size batteries. And I get them at a local batteries here. I think it's US Batteries where I purchased them from. So, but this is older lead acid technology, which is one of the reasons why I like to keep the batteries at a high level of charge. They do not like to be discharged more than 50% to maintain a pretty good life of them. And the less you discharge them, the longer they last. So that's why I try to maintain at least a 90% charge on these batteries. In the future, when these batteries wear out, I do plan on going to lithium batteries, where you can bring them all the way down without hurting them. They have BMSs, which controls the batteries, prevent them from being damaged if they're too low. But you can bring them 80% down without any life being lost out of them. But they are a lot more expensive, so I'm waiting for the price of those to come down, and hopefully these will last long enough to where the price will really drop on the lithium batteries. And they're working on battery technology like crazy right now for the electric vehicles. So what's good for electric vehicles will be good for renewable energy if you're wanting battery backup.
Here's another question that pertains to, is this an all-electric property, or do you have natural gas? And the other component is, do you have a geothermal system?
We do not have a geothermal system. We do have gas. It's not natural gas. We do have a propane tank. It's a 500-gallon propane tank that we can use for. We have one radiant heater in the house that we operate off of it, and we do use it for the barbecues that we cook outside. Normally we cook outside in the winter or in the summertime to keep the heat out of the house. And there is one gas or a small gas stove in the house, along with electric range, which is a inductive range. On times when there is very little solar or wind available, instead of the wife using the induction range, we will use the gas range. But this 500-gallon tank, which only holds 400 gallons, because legally you're only allowed to fill them 80%, lasts us approximately 4 to 5 years. And the other source of heat that we have is a wood-burning stove that we only use on very, very cold occasions because it overheats the house real easy. It's got a secondary burn chamber in it, and it reignites any smoke, so you don't see any smoke coming out of the fireplace, and it puts out a lot of heat. And we use it only on the coldest of nights. Most of the time we'll use electricity to heat the house with in the wintertime. We used to use little portable electric heaters, which, you know, they claim to be 100% efficient, which they are. However, what I've discovered is most of them are rated at 1500 watts, and they put out about 5,000 BTUs, which is not really great. They do use a lot of electricity. So we opted and put in a couple of mini split heat pumps. So we put in a 1,000 or a 1-ton unit and a 1.5-ton unit. Now, compared to the little electric heaters, the one that uses 1,500 watts and puts out 5,000 BTUs, the 1-ton unit will put out 12,000 BTUs and uses under 800 watts of electricity. So it is a lot more effective to use heat pumps or mini splits for heating your house. So as long as it's warm enough outside, if it stays above freezing, we use the mini splits. After that, they'll still put out heat, but they're not nearly as efficient. We will then use propane from time to time with the radiant heater until just to boost the temperature in the house just a little bit. If it gets extremely cold out, then we'll light the fire in the wood stove. And we have ventilation that's hooked up to it that can also take that warm air and put it upstairs into the bedroom area upstairs through some vents through the wall. So basically, most of it is used with electricity that we generate.
Mm-hmm. Here's another question. It's more of a comment, and it reads, you can often find lightly used backup batteries which usually work well. I own one 170 amp hour and 200 amp hour AGM lead acid batteries for backup. My batteries are 12 volts. It's, I guess, a comment.
Yeah, those are similar to the batteries that we have in the garage. They're AGM 12-volt batteries. I think those are rated at 93 or 94 amp hours, which are real similar to those. And we put a bank of them together to raise the voltage. We went with a 48-volt system due to when we transfer power from one end to the other, you have a less line loss. And also they make a lot more higher kilowatt systems for 48 volts than they do for a 12-volt system.
Okay, here's a very interesting question. It says, what are the life cycle of the batteries and what is your plan to dispose of those batteries?
The life cycle on the batteries, of course, depends on how you treat the batteries. We take great care of our batteries. I keep the water checked in it all the time, and we keep them at a high level of charge. The small golf cart batteries that we use have the shortest life. They last between 6 and 7 years. The larger industrial batteries, there should be around 10 to 13 years. And we'll never dispose of a battery. We recycle the batteries. Batteries are recycled. You take them to a recycle center, or when you replace them with other batteries, you will turn them in for a core charge. So they're never really disposed of. They completely recycle the lead and everything into the batteries, which makes it a lot more environmentally friendly. I know batteries are nasty things, but they are almost 100% recyclable.
Okay, before I take the next chat question, I have one for you. Your water heater, is it uses a typical water heating element, or are you using a dedicated solar water circulation system that feeds your water tank?
in the past, we had a solar water heating system that heated our domestic hot water. It's a system that I bought back in the early 80s. And when the people bought our house that we lived in Arlington, they didn't like the way it looked. So I took it off of the house and we installed it in the house here. That system supplied probably around 85 to 90% of all our hot water. A few years ago, I started having problems with it. They were batch collectors that sat on the roof, and the tanks started leaking a little bit, and I was not able to fix them. So I took those water heating panels off of the roof, and I put an extra set of solar panels on the roof. Our water heater is a conventional 55-gallon electric water heater that has 2 elements in it. Now, some of the modifications I've done to it is we added a timer to it to where the water heater only comes on during the day when we're making maximum power with the solar system. I've also added extra insulation and wrapped it up really good with insulation and put a radiant barrier around it so that the water temperature stays pretty constant for a long period of time. The other modification that I did, the elements inside the water heater run off at 240 volts and they consume about 4,500 watts apiece. I did not want to put that big of a load on my inverter because no telling what else I had on at the same time. I didn't want to run my inverters maxed out. So I disconnected one leg of the 220. So my water heating elements now run off of 120 volts, which now means they consume 1/4 of the power. Instead of 4,500 watts, they consume 1,100 watts. Now, the disadvantage of that is it takes longer for the water to heat up. But with the water heater insulated so well and with a timer on it, it doesn't tax my system. The water stays hot and we have never run out of hot water. So the extra PV solar panels helps to heat the hot water. I love that. There's no plumbing involved and it was very easy to do that.
Interesting. So here's, I don't know how to construe this next one. Maybe he's thinking out of the box. His comment is that you should get an amateur radio license and make additional use of the tower for antennas.
Yes, I've had people approach me from that. I've even had some cell phone companies approach me about wanting to utilize my tower to put cell phones on. However, I really don't want a commercial unit here. I decided not to do that. The tower does vibrate, even though it doesn't move or anything, but it does have vibration. I was afraid that maybe equipment problems might be a problem. I do supply power to an amateur radio club from time to time during their field days with some of my portable solar units. And I've thought about getting into amateur radio. I do have one here and I do have an antenna on the house. I don't use it very often. I don't have a license. I listen from time to time, but that is something that I still may consider in the future.
Eric.
Yep.
I guess we have 4 minutes left.
I have a question. Look, let me say, hello.
Yes, sir.
Hey, Mike.
Yes.
I was typing away. You know, you did the hot water, the heating, running piping through a floor, Roman style sort of hot water.
Yes.
Right. Did you consider using the Yankee style baseboard trim? Because in houses in New England, they have hot water systems that go around and around the room, and they're generally fueled by I don't know, by heating oil, but they go around the perimeter. And I was wondering if you even thought of if that's something you considered, because I could see how it could be solar powered and it wouldn't have to be embedded in plastic or in the floor.
Yes, I have considered that and done some research on it and discovered that those units running off of hot water really require a high temperature in order to get very much heat out of them. So what we have done instead is when we added this front room to the house, we incorporated PEX tubing into the foundation. So we also heat water with the solar panels in 2 tanks, which we have a combined 135 gallons of hot water that we can store that runs through the floor in radiant heating. The slab is insulated from the ground. So during the wintertime, we heat that slab and you can heat it with 100-degree water, 80-degree water, and that slab becomes warm very quick. Well, not very quick. It takes a while for it to get warm. But once it does get warm, it takes a long time to cool off, which there was a learning curve when we first installed that. We got the slab real warm and then it overheated in the house because you can't cool it off real easy. So there was a learning curve on how to operate that. But using a radiant floor heating system works great with solar. Whether you heat the water directly with a solar water heating system, or as we do, we use PV to heat the water with the resistance heating. So that is a great benefit that we do have.
That would be, but in new construction, yes. In retrofit, would it be practical to, sort of run things around, or no, in your opinion?
It can be done as long as your system is be able to produce at least about 160 to 180 degree water, which those types of systems require. So it is possible, and it can be done.
But
Mike,
one effective is forced hot air.
One very quick question from the chat room, because it's almost 2 o'clock. Are there any EV chargers in your
Thanks,
future?
Mike. I'm checking out.
Okay, say that again, Dharma. I missed it.
Are there any EV chargers in your future? Less than 30 seconds.
I would like to have an EV. Yes, I would like to have an EV in the future. I would also add some more solar. If I do get an EV, we're probably going to add like a carport out in the front and put solar panels on it. As of right now, I drive a Toyota Prius, which gets great gas mileage, but in the future, I would like to have an EV. Yes, that is definitely on my list.
We can run over a little bit, Dharma. We don't have to shut everybody off if there are other questions.
Okay. Any questions? And a compliment from one of the attendees. This is a great do-it-yourself house story. Thanks to Mike for a great presentation. Thank you, Mike.
You're welcome.
Hey, thank you, Mike, for a great presentation. And your house is always a showcase. So thank you.
I want to thank everybody for attending. And if you want to learn more about my house and my system, I am a member of the North Texas Renewable Energy Group. I do attend monthly meetings. That is, whenever we'll have the next meeting, whenever this COVID thing ends. But there are virtual meetings going on right now that everybody can attend to. But I absolutely love talking about my system and how you can implement different things in your own life.
Well, I had a question, Mike. There are 2 inverters in the house. How do you work that for putting power out to the house? You have 2 separate circuits in the house, one that runs each inverter?
No, the 2 inverters are tied together and they are synchronized, so they act as one inverter.
Oh, so basically you have 12,000 watts then?
Right, right.
Oh, cool. In your power center, what's the large black box off on the left there? Is that what is the combiner, basically?
The black box off the left is actually a secondary AC load center. There's where circuit breakers are at that feed different parts of the house.
Oh, that's what it is.
Yeah, the white box off to the right near the bottom is the DC circuit breakers that disconnect the inverters from the battery. The black box on top of it is the charge controller for the solar panels up on the roof.
Oh, okay. Neat.
So the inverters are synchronized together. They'll put out 120, 240 volts, just like your conventional power that you get from the grid. And they share the load. So they're capable of putting out 12,000 watts. If we're using 6,000 watts worth of power, each inverter is now producing only 3,000 watts. So that way you keep the power consumption on them low. It's like driving a car. They last a lot longer when you drive it slow as compared to driving at 120 miles an hour every day.
You know, I was thinking what Michael was asking about the EV chargers. I was thinking this morning, the EV chargers are usually like a 7 kilowatt load. I thought, gee, a 6 kilowatt inverter couldn't handle that, but if they're working together, you'd be able to handle it easily.
Yes, yes, they would. And they also have a very high surge capacity. So if you have a large compressor or large load coming up, they can surge at almost double that power level.
Mm-hmm. Yeah, so you'd be able to take the startup from a big motor.
Right.
Mike, what other future embellishments are you looking at? Looks like you pretty much exhausted all options possible. Are you thinking up any new ideas that can be tied to a solar system?
Well, like I say, in the future, I would like to get an EV. I would have to upgrade a little bit to do that. I'm always finding new ways to make the house energy efficient. We have our own rainwater collection system. We have our own well, which we all powered with the solar system. So I always come up with ideas of how to make things more efficient. Always looking for ideas, whether I come up with them myself or go to meetings and find ideas that other people have that I've never thought of. So going to meetings, a lot of times I get some ideas from people that I have never thought of that are really great.
Now, one of the ideas that came to my mind was, have you considered setting up a little fuel cell system there to produce hydrogen for, you name it, any use?
Yes, I actually looked into some fuel cell systems, and there's actually a company, I think, out in West Texas. They were out at the fair that they had out there at the fairgrounds in Dallas, and I had talked to them a few times, which that is a possibility. Solar would be a great idea of how to produce hydrogen. Oh, that is something that I had considered about, not really actively, but it is something that I can look at in the future.
Although I think it's not as efficient as using batteries. I think the turnaround from taking the power in to what you get out is not, the batteries are like 70, 80% efficient, and hydrogen is only 35 or 40% efficient.
Yeah, that is true. The round trip of hydrogen consumes a lot more energy than batteries would, especially when you keep the batteries at a high level of charge. Very little energy actually is used by the battery itself, keeping them at a high level of charge. Now, if you deplete batteries and charge them back up, now your round trip really increases with the amount of energy that's really required. But if you keep them at a high level of charge, it makes them a lot more efficient.
Great.
At least with lead acid batteries. The internal resistance is not as great as it is with lithium batteries. Lithium batteries have a real low internal resistance, so the round trip of lithium batteries is much better than lead acid batteries.
I think to your list, you could even consider adding up those flow batteries. They seem to take away some of the issues with the lithium.
Yeah, I haven't really considered flow batteries, but I do want to eventually go to lithium batteries in the future. The lithium iron phosphate batteries is something that I am considering. So that may be something I would want to do in the future.
Yeah, there's a lot of work on those. That company in China, CATL, is doing a lot of work on them, and Tesla's using that in their cars, but they're talking about those being kind of the best option, or a very good option for stationary power.
Yes. Yes.
They have the cycle life and lower costs, and lots of benefits associated with them.
That is my next step.
Oh, neat.
And I've
Just
also
waiting
heard
for-
that from a resource perspective, lithium sourcing in the US is getting to be a little tight.
Yes.
So you're dependent offshore for bringing that. That's where the flow batteries might probably fit the bill.
Yeah. They are working, there's so many companies and universities that are working on batteries. And I can't hardly wait for bigger breakthroughs to come in to make them cheaper and a lot more efficient. I believe that is a coming thing in the future, not only for electric cars, but utility companies are also investing in them and looking at them for stabilizing the grid.
Mhm.
So I believe that is a thing of the future that's coming pretty quick.
Yeah, it looks like they'll be used possibly for to replace peaker plants, because they have
Yes.
a good kind of power capability, and also the time duration. They're theoretically not great for long-term energy storage, but for a day or so and dispelling the power in a short period of time, they're excellent.
Yeah.
I guess now we are getting close to our time limit. They said don't go past 15 minutes overtime, so we're getting pretty close to that.
I wouldn't want to deprive anybody else of their time.
Yeah, that's right. Thanks everybody for listening in. Thank you very much, Mike, for letting us question you about it.
Thank you for everything.
Sure. All right.
Thanks.
All right.
Bye.
Have a good evening.
Take care, folks. Have a good afternoon.